Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. This video will be part 4 video of my SolidWorks mini vacuum cleaner project. In my previous video, in my part 2 video, I have already shown you how I have done little bit detailing for this front and rear casing. I have done the 4 pins here of this rear casing, bigger pins, and I have 4 pins, smaller pins for this front casing. Actually, this pins is meant for the fastener, the 4 screws to be fastened to join the front and rear casing. Okay, in this part 4 video, I will show the continuation for detailing this front and rear casing. Alright, okay, to tell you, I have done in my previous video, I have done the impeller and also the rear cap. Actually, I have also done the part modeling of the DC motor, this rechargeable battery, and also this PCB. For these 3 components, the DC motor, the rechargeable batteries, and also the PCB, I will not show you how I have done this part modeling of these 3 components, since these 3 components are standard parts. Alright, in this video, I will show you the complete detailing of this front and rear casing. Alright, in SolidWorks, when you do detailing for this case, like this mini vacuum cleaner, the front and rear casing, you cannot focus on the part modeling to complete every single detail structure of your either front and rear casings. Because when you complete a detailed part modeling for a single part, for example like this rear casing and also the front casing, later when you do assembly, when you try to assemble to do the mate setting to put the position of your motor, the impeller, and also the batteries, always it happen that these 3 components does not match in assembly, because maybe the component you make a separate part modeling during assembly in SolidWorks, it will not match. Sometimes it's not fitted to your supporting structure that you have done. So the way to do it, better to do this thing, the detailing of this rear and front casing, for example the supporting structure here to hold the batteries and the supporting structure to hold this DC motor, better we do it in assembly mode. So it means I will open assembly mode in SolidWorks, then I will position all the inner components here, the DC motor with impeller, the rear cap, the battery, and the PCB in the exact position. Then only I will know, I will edit that. For example, this is a front casing. After I have positioned all these 3 components, all the components inside this casing, then only I know where to build my supporting structures to hold this battery, supporting structures to hold this PCB, and also supporting structure to hold this DC motor. It means that I put all these components into the exact position, then only I build the structures in assembly mode in SolidWorks. Alright, so I will show you how I will do this in SolidWorks. So let's get started in SolidWorks. Okay, in SolidWorks, okay, I will open a new file. So I will not go for part modeling, I will go for assembly. So then I click OK. Okay, now we are in assembly mode. Alright, the first thing in assembly mode, so SolidWorks will ask for your components to be inserted for your assembly. Alright, the first thing to do, I will select the base component, which is the main body. Since I've done the main body before in my previous video, the main body we have 2 parts, which is the front and rear casing. I've still not yet separate this main body into front and rear casing. So I click at main body, so I click open. Alright, now here I will not click on the screen for your base component, which is the main body. So I simply bring my mouse here and I click OK. So what it means is that in this assembly, it will be inserted in at the origin point. If you look, the interface of this assembly is kind of like different from part modeling. Here we have a feature manager here. If you look here under this feature manager, we have the list here. So main body is there. If you look at the main body, it have bracket F. F means fixed mode. It means I cannot move this main body. It's in fixed mode. Alright, Okay, another thing is that after I put the base component, which the main body, I need to off, since I need to focus on the, actually at the back is a front casing, at the front actually is a rear casing. Okay, I will open the list at the main body. If I open the list, so here under solid body, so I will select the front casing, I hide it for a while, so I just need to see only this casing, the front casing. Alright, the next thing is that if you look the interface of this SolidWorks assembly, under the assembly we have a menu above, so you can insert the component. So I insert the component. I will not insert all the parts that I've done, like DC motor, everything here. So what I will do, I will only insert the relevant part first. What I mean relevant parts, I will insert the DC motor and the impeller first. I do it one by one. Alright, so I will insert the DC motor and also the impeller. Okay, now I put the impeller and the DC motor. What I will do, I will position it into the exact position in my assembly. You cannot simply drag it like this. No, that's not the right way to do in assembly. To position your component in assembly, you have to do mate setting. Okay, if you look under the assembly here, we have another command here, mate. So if I click at mate, okay, if you look the setting on the left here, we have here mate selection. Here if you look here, the mate type, we have all the relation that we can choose for mate setting. Alright, so I will select the first relation. Since this DC motor we have a cylindrical surface, so I will click at this cylindrical surface of this motor, and it will mesh with the, I have the cylindrical surface of this casing. I will select that cylindrical surface. Automatically SolidWorks will detect the relation is concentric. Okay, I click OK, so I have the first relation. Okay, I just click OK first to terminate the mate setting. Now I have the first relation, so it means that this DC motor is in concentric position, so it can only move forward and backward like this. Alright, but it remains concentric. Alright, then I will go, okay, let me drag it like this. So my another mate setting, I click at mate again, and now about this impeller must be attached to the shaft of this motor. So I will do another mate setting, so I will select the cylindrical surface of this impeller, and it will mesh with the shaft of the motor. Automatically SolidWorks will detect it as a concentric, but here if you look, the turning of this impeller is in this direction. I need to make this impeller turning to the other direction. To do that, if you look the setting on the left here, by default the mate alignment is the left. I will click at the right for anti-align. Anti-align we go to flip position, then I will click OK. Then now I have a relation of this concentric of this impeller and also the shaft. Okay, my another mate setting is that, alright, my second mate setting, hold on, let me click OK first. Right, so I reach the second setting. Okay, I click at mate again. Now I want this surface must touch this surface. Automatically it will goes for coincident, and I click OK. Right, if I click OK here, then I have the setting for this impeller and this motor. So it means that this motor and this impeller in position, but I still need to place this DC motor into this position to be at that exact position. Okay, let me drag it here first. I put into this position. Okay, the idea is that if after I put this motor and impeller in exact position, then only I can build the supporting structures or the ribs to hold the motor. Alright, to do this I need to set another mate relation. It's about this surface and the surface, the distance. I need to give some value of the distance. If you look at this photo, if I zoom in, let me show you again this photo. If you look at this, this photo, okay, this photo is turning to this direction. Let me flip horizontal, so it goes to the direction. Okay, if you look at this photo, so we have this motor and the impeller is at this position, it means that I need to set the distance between this surface and the surface of the impeller. So I need to give the distance between this surface and this surface. Alright, so in SolidWorks it means like this. So I will go for another settings. So I will go for main. So okay, under this main setting, so I will set another relation. So I will select this surface and I will select this surface. Automatically SolidWorks will go for coincidence. So here, if you look setting on the left, so I can play around with distance here. If I click at the distance, if I put the value about 10 millimeter, so it means that, so this is 10. Let me check. I think 10 is, if I put it 10, as you can see, kind of like the impeller is too close to the surface. I don't want any interference happen. It's not touching any component inside. If I go for 12, to check the distance, if I go for 12 and the back surface of this impeller is not touching this pin, I think 12 is okay. There is no interference. So I go for 12, I click OK, and I click OK. So now my motor and impeller is in position. Alright, I cannot move it forward and backward, but I still can rotate the impeller. As you can see, the impeller can still be rotated. Alright, another thing about this motor here, as you can see, I have a metal connector here. I want this metal connector to be in vertical position, in vertical like this. So I will do another relation for my mate setting. So here, mate here, if I click at mate, so this is the motor. If you look the list here, let me close this list. On the screen we have the list. So for the mate selection, the blue color, I will select the list here on the screen. I will select the DC motor, the front, what I mean is the front plane, of that DC motor. Since the front plane laying in the middle and is in line with the metal connector of that motor, so this is under the list of motor front plane. So I want it, then I close this list. So I want it to mesh with the main body. If you look, the main body is not front plane. The main body will be the top plane. So if I select top plane of the main body, so as you can see, both those two planes are in line. Then I click OK, then I click OK. As you can see here, now my motor, the DC motor is in position. I mean the metal connector is in this mode. What I mean is in horizontal mode, that is. Alright, what I will do, I will save this assembly as assembly 3. I save it. You need to save your assembly file. It's already saved as assembly 3. Alright, now since my motor is in position and in fixed position, now I will do editing of this casing here. So that's how I do things in SolidWorks. I will do it in assembly mode. Okay, this is assembly, and you can edit your part in assembly mode. Since I want to edit this casing, the casing file is a main body. When I click at this main body here, and we have a menu here, so I go for the fourth one here, edit part. If I click at that edit part, so now if you look the icon here, upper right corner, we have edit part. And also if you look the list under the feature manager, the main body turns to blue, right? Blue color. So it means turns to blue, it means that we are editing the main body, right? We are editing the main body. If you look the other components, the other parts, which the motor and also the impeller, it kind turns to transparent. Alright, now I'm editing this main body. If you look the interface here, it becomes similar like part modeling. Alright. Okay, since here, if I turn my viewing direction like this, I want to create a supporting structure to hold this DC motor, and I need to build. If you look at this photo here, hold on, if I look at this photo again, I show you. Okay, since this photo is turning to the other direction, I go for horizontal flip. Let me show you again close-up version for this photo. And I need to build a supporting structure like this, kind of like a box section like this. Or maybe I will do different version. Let me try it. I will show you in SolidWorks. It's kind of like this to hold the motor like this. Alright. Alright, so in this assembly mode, now I'm editing this main casing. Alright, so what I will do, since the interface like part modeling, so I will select carefully, make sure your viewing direction is like this. I need to go to the certain plane for me to build the outline, for me to create the supporting structure. So what I will do, okay, if you look here, I will create similar like this one. So we have kind of like a C shape here, like this, right? So it means I will create plane at this level. First I create a plane at this level. So it means that in SolidWorks here, I'm now editing this main body. The motor and the impeller turns to transparent. So I need to create a plane somewhere at this level. So I will carefully select. Okay, if you look at the interface here, features, we have a reference geometry plane. The first will be carefully select this plane, and the level I will go to flip offsets. It will go to this level. I will go for about if I go for about 5, about a certain level, kind like we have the first supporting structure at this level. It will support this DC motor. As shown here, is about at this position. It means that I will go for a distance of about, I think it is good enough. So it will be my plane. So this will be the plane for me to create a sketch. Alright, so I select this plane. Okay, in here in assembly mode, the way you editing this plane to make a sketch mode, so you have to do it like this. I'm now in main body. If I scroll here, I have a plane 6. I click edit and I do sketch. Now I'm this viewing direction, so it means at this sketch mode, so I will trace the outline of this DC motor, and I will convert entities, so I have a trace sketch there. Okay, if I exit the sketch, so now I have this thing. I need to show you, I do it part by part. First I do the supporting structure to create this. So if I exit the edit part mode here, so now I'm back in normal mode in assembly. Okay, one way to further detailing of my main body here to create a supporting structure, I can do it like this. I select the main body, and here we have the second one, open part in position. So it means now it will open this main body file as a typical part modeling. Okay, now I can edit this sketch, and I will do editing of this sketch. I will create kind like supporting. I will create a line like this. I will create a line little bit at this position, and this line is actually, this is vertical because we are looking at this viewing direction. So about that much, and I will give some distance from here to this line. It's about, I go for 3 mm, and also the distance here I go for only 1 mm. The 1 mm will be the thickness of the wall for me to, later I will show you. I make it 1 mm, and also I have on the other side, so I will do a mirror. Make sure this one is vertical like this, and it goes like that, and I will do a mirror. I want to mirror this line, and mirror about is at this position. So I have this thing, right? So this will be my outline, and this one I can trim it. So I have the outline there. But now I need to create, I will not create a rib, just to show you. If I create a rib features, if I create rib and I give the thickness of the rib is 1 mm, and the projection of the rib I make it downward, and this one select the body. If I do the rib, so what rib will do, it will create a solid wall. It will connect up until edit surface here. So I don't want to create rib for my supporting structure. Let me undo, delete the rib. What I need to do, I need to edit the sketch. Alright, the sketch I edit it. What I need to do is that I create a line, I will create a line. It goes down up until it touch that surface. So I can trace this one, because since this is at this position, so I will select this edge and I convert to entities, and this trace outline will be at this plane 6 level, and I will create a line. I will create a line at this position, make sure it's vertical and it touch the line, and same goes to the other side. This line I go like this and it will touch to this line, and this one I can trim. I can trim this and I can trim this one. So I have the, then I can do extrude to make a wall. So my wall direction, if I extrude, it's not that direction, so I go for thickness 1 millimeter to that direction. So this would be my supporting wall to hold the motor. If I save my file and if I go back to the assembly mode, since this is a part modeling, as you can see, if I click yes, it will be automatically updated in assembly mode. So in assembly mode, we can see either the way I do the detailing, the supporting wall here, the supporting structure, is it fit to the motor. Alright, so this is how I do things, editing the main body in assembly mode and going back to the part modeling. See, it kind of like have a dynamic link. Okay, my next move, since I've already created a thin wall supporting this DC motor here, so my next move, I will create a line like this, and I will create kind like a wall like that, it join like this. Okay, in assembly mode, okay, since I've created this thin wall here, so I will do edit part, and I can use this plane as my sketch plane. Now I can start creating a line from this point. Okay, sometimes it's hard for me to trace the, so I go for display style hidden line. So I will click at this edge and convert entity, so I have that line. Then I go back to shaded mode, then I will create a line from this point, and it goes like this, and this line I make sure that it join like this, and same goes here. So I will create this line at this point, it goes like this, and this one make sure that it coincide. Okay, now I have the outline here for me to create. I will do offset to create the extension as shown here, this kind of wall. So here in, I will go for offset, I give the value of 1, make sure selection is on, so I click like this. Sometimes if the direction is inward, I will go for upward like this, and make sure that cap ends and line is on. Then I click OK, so I have the outline. Then I will do features, extrude, then I will go for reverse direction, make sure to use up to body, then I select this body, then I click OK. Now if I exit edit part, now I have these features, the complete supporting structures at the front end here to hold the motor. Okay, if I hide the impeller for a while, alright, I have these features. I have a wall, jointed wall like this. It's kind of like it will prevent the motor to be moved to this direction, kind of lock the position of the motor. But I think I will do so, I will open part in position, I go back to part modeling mode. Okay, here in part modeling mode, I need to create, since we have a solid wall like this, I want to create a cutout of half circle here. So I will click at this plane, so at this sketch mode here, so I will create a circle, just put somewhere at this position the circle, and I set this this circle and this circular edge, then I set relation to concentric, so it means that it share the same center point. Okay, now I give the diameter of about 18, then I will do extruded cut and make sure it's up to surface this direction. So I select the surface, so it will end up at that surface. So I have a cutout. Right, if I save my file and if I go back to the assembly mode and I click yes, so we have this thing, right? We have this thing. So this is how it looks like for this supporting structure for this front end. Okay, about the other end, I will repeat the same procedure as what I've done for this front end supporting structures. So here in assembly mode, I will go for edit part, and now I will create like this one. First I build the thin wall here. So for at this end, I create somewhere at this level a thin wall as shown in this photo. I will create at this thin wall like this, and right here, so I will use here, hold on, so here the features plane, so I will carefully select this plane and I go to flip direction. Okay, I give some value about not 5, let me go for 8 about this level. Okay, 8 is good, so it means at this plane. Alright, at this plane, so here if I open the list of the main body, so the plane 7 is there, so I will create a sketch at that plane. So it means that I will select the outer edge of this motor, then I convert entity, so I have the outline, exit, and I exit edit part, though I open the main body, open part in position. Now I'm back in part modeling mode of the main body. Alright, so here I will edit the sketch. Similar procedure what I've done for the front supporting structure. So I'm editing the sketch, so I will create a line at this level, about that level. So this line is somewhere at this level, then I will put a dimension from here to this point. It should be 3 mm, and also this distance is 1 mm for the thickness of the wall. Alright, so I will create center line from here, make sure it goes vertical and it touch the quadrant, and I will do mirrors. Select this line and mirror about it, this center line, so I have this line. Alright, and now I can trim here. So I have this outline, so I need to make a line attached to the surface. So I will use this edge. I will track this edge. Hold on, I will track at this position. If I go for this viewing direction, so I will select this circular edge and this one convert entities. So I have the trace outline, then I will create a line from this point, make sure it goes vertical like this and it touch this point. Right, same goes here, so I will create a line from this point vertical and it touch this point. Then I can trim this one and this one. So I have this outline for me to create a wall. So I will go to features, extrude, thickness is 1, thickness is 1, then click OK. Okay, now I have the thin wall. Okay, let me save my file, the main body part modeling file. Alright, if I go, okay, let me save it again, and if I go to the assembly and I click yes, and as you can see here, I have the thin wall. Alright, let me save the assembly file. Now I'm doing editing, so I click at this. I'm now in assembly mode, so I will go to edit part and I will select this surface here to create a sketch. And it's hard if the shader is the display style in shaded mode, so I will go for hidden line, so I can select this line, convert entities, then I go back to shaded mode, then I can create a line from this point, mesh horizontal, mesh like that, and this one coincide, and also the line here from this point horizontal, and this one touch to this point. Alright, so I will go for offset 1 and select this one and measure caps and lines, then I click OK. Now I will go for features, extrude downward and up to body, so it will touch this body surface. Alright, let me save my file first, and if I exit edit mode, now I have this thing, right? Okay, let me edit back here. So this is still main body file, edit part, so I need to create at this section, at this plate, I create a sketch. So I will go create a circle just somewhere at this point, then I will do relation this one and any circular edges here, hold on my control key and I go, so it share the same center point, and then I click OK. So about the dimension of this is similar like the front end. I go for 18. Alright, I go for 18. Hold on, I go for 18, and I will do features. Sorry, I will not post extrude. I go for extruded cut up to surface, and make sure that it stop at this surface, right? Then I click OK. Now I have the cutout. If I exit edit part mode, now I have the, if I save all, right, if I go to open part in position, now back in part modeling mode of this main body file, I have this supporting structure, right? Okay, one more thing I need to mention, what I've done here for my casing here. So I've done the 2 supporting ribs. Actually the actual product is on this direction. This is actually the front casing. What I've done, we have a 2 supporting structures, but it's facing to this direction, but mine I make a mirror representation of it, so it goes like this. So it means that I create it on the rear casing. So I think it's okay because mine kind like a mirror representation. So I will later I will show you how I will do the cutout for this rear cap, and also the supporting structure to hold the PCB and also these batteries. Okay, then my next move is that I will do the cutout, since we have the rear cap here, the orange cap at the back. So it means we have, if you look at this photo, we have a cutout here. Alright, in order for me to create this cutout where the orange cap will fit into this groove here, since the orange cap we have kind like these features. In order for me to do that, I cannot do it in assembly mode, since this is assembly mode. So what I will do, I will go for directly to open part modeling. So this is part modeling of this main body. Also in this part modeling, we can insert a component like we have done in assembly. So since this is part modeling, I can also insert here you have insert, you can insert your part. So I will insert the rear cap, then I just simply put somewhere at this position. Alright, this is part modeling mode. This is not actually as assembly mode. Okay, if I want to move this rack cap into the right position, so in part modeling mode, I can do that by insert features. I can move copy. So here, okay, your setting is not like this. I will go for mate setting by using the constraint relation. So I will click at constraint. Alright, if you look at the settings here, it's kind of like similar like assembly mode. The only difference here, I need to click here, the bodies to move is this rack cap, since I want to move this rack cap to be put into the SX position. So under body to move, I will select this rack cap. So it's already selected. About the mate setting here, so I will use a relation. So I will select the cylindrical surface of this rack cap and the cylindrical surface of this main body. Automatically SolidWorks will detect it as concentric. Then I will click at add, so it means it's already read the first relation. The second relation, I will select this surface and this surface. SolidWorks will put it into position like this. It will be coincident, right? So I don't want it to be coincident. I want to put some distance between those two surfaces. Here I have a distance option, so I will go about 2 mm. So it means that it's kind of like in this position, similar like one that you see in the, if you look at the photo here. So we have this one, I want to make this kind of cutout. Later I will show you how I will use combine subtract. So alright, it's about that position. Then I click OK. So I have the rack cap in position. Alright, since I have another front casing, I already hide it. So because my front casing is hidden, so what I will do subtract to, this is a rear casing, I will do subtract. It means this rear cap will be subtracted from this main casing to create a cutout. Before I do subtract, I must clone this rear cap because I have another one is for the front casing. To clone this rear cap, under insert here I have features. I will go move copy again, but this one I'm not using the constraint relation here, mate setting here. I will go for translate rotate. So under translate, under here the setting here, we can move and copy body. So make sure the copy is checked. So bodies to move, I will select this rack cap. I will not move it. I simply select this rack cap, so it already listed here. So make sure copy is checked, and I want to make one clone. The number of copies is 1. So I click OK. I simply click OK. Now I have a clone version of this rack cap. As you can see here, under the list of solid body, I have the original rack cap, and this one I have the clone version. Now what I will do subtract by using insert. Okay, I will use insert features, then I use combine. We have option. I'm not using add. I will do subtract. Subtract means the main body will be this rear casing here, and bodies to subtract, I will select the clone version of this rear cap. So it's already selected. If I click OK, now as you can see, if I hide this thing, if I hide this, the original version, now I have the cutout. Alright, I have the cutout. Alright, about the other one, about if you look at the front casing, and the clone version of the rack cap, I on it and I hide the rear casing. So for the front casing, I will do the same. I will do subtract. The features I have combined, so the main body will be this front casing. Bodies to combine, I use this one. Make sure this one is subtract, then I click OK. Now I have the cutout for the front casing. Right, let me on back the rear casing. Now the rear casing and the front casing, I have the cutout. So it means that I've saved this file. Then it means that in assembly mode, in assembly mode, it will be automatically updated. I click yes. Now in my assembly mode, I have a cutout. Alright, let me hide this front casing by open the list here. So I will hide the front casing. Right now, since front and rear casing under the same main body file. Alright. Okay, so I save my file again. Right, the next thing to do is about this. This is a rear casing. If I on the front casing and I hide the rear casing, as you can see, my front casing still I've not yet created the supporting structures. Okay, if you look at this photo, so this is the actually this is mine is like this. Alright, so this is the front casing. So I have these pictures. I already done the at the rear casing the supporting structures. So now it's about let me undo this. So I want to create this for the front casing. Similar approach. So I will do so this is a front casing. I will create these supporting structures like the one that I've created for the rear casing. Okay, let me show you for this front casing. I will do similar approach. So I will, this is in assembly mode, so I will go for edit part, and now I will put a plane, the position of the plane where I will create at this position first. I will create at this plane first. Let me clear this thing up. So I will create the first the thin wall here at this, and then I will show you how I will do linear pattern to create a similar thin wall at that position. Alright, so in assembly file here, I'm editing this main body, and means that so I will hold on, I will use reference plane. So I will select this plane, and I will go for flip offset, and I will go about position. I think 20 is good enough. I go to this direction, flip offset, by checking flip offset at this direction. So this will be my plane from at the end of this motor is 20 units. So this plane, so this the new plane I've just created, and here I cannot edit it because they are in assembly mode. The plane 9 that I've just created, I click like that, so I will make a sketch on that plane. So this is a plane 9. So here I will go for the outline of the DC motor here. So I will convert entities, so I have a trace outline there. Now I exit the sketch mode and exit the edit part mode, and I will go for click at this main body file. So I open part in position, so I will go back to part modeling mode. I'm now editing the front casing of this main body file. Alright, so here I will do the similar approach like what I've done for the rear casing, the supporting structures. So I edit the sketch. So it means that here I will create a line somewhere at this position. So this is make sure that it goes like this. This actually is vertical because the viewing direction is at this orientation, right? Make sure this is vertical. Then I will put a position from this line to this center point here. I go for 3 millimeters, so it goes further deeper into this position. Alright, so then I will go for this one is 1 millimeter to create the wall is 1 millimeter, and then I will do a center line from this point. Make sure this one it goes horizontal like this, and it snap at this, and I will do mirror, and mirror entities is this line, and mirror about is this center line. So I have the mirror representation of the line, and I can do trim now. I can do trim, then I will do a line up until this surface. Alright, okay, in order for me to do that, similar approach like what I did. So this at the level, this level, so I will trace this circular edge. Hold on. I will trace this because I select this circular edge, so convert entity, so I have a trace outline of that circular edge here. So I will create a line from this point. Make sure this one it goes horizontal like this, and it touch at this point, and same goes here from this endpoint. Make sure it's horizontal and it touch this line. So I will trim, I will trim this one, so I will trim this one, so I have the outline for me to create the wall, right? So I will do features, extrude, and I go for thickness of 1, that direction, this direction, then I click OK. So I have a thin wall to support the motor. Alright, but this thin wall is still not enough. I need to make it something similar like this. I have a duplicated version there. Okay, another thing, and one way to do this, so it is something new for you. So let me hide this plane. I don't have to repeat the same process here on this side, so I can do by using linear pattern. Since there is kind of like a linear direction, I want to make a clone version, a linear pattern by the number is 1, copy count, the number is 2 counted from the original, right? So we have an option here, linear pattern. Linear pattern means so the direction will be, I can use this edge, because this is the direction of my linear pattern. I can take the straight edge of this main body here. So it's already stated here, the H1, and about the distance I can go for 10 mm. So it means I will make a copied version of 10 mm from this original one to this direction, and the number is 2 counted starting from the original. The number is 2, and here that I will not use direction 2 because my linear pattern is only one direction. About the features, so I will select this thin wall that I have just created. So I have, as you can see here, the distance is actually 10 units. If I go for 3, so it means I have 3, so I just need to start from the original. So I have, if I click OK, so now I have the linear pattern of this thin wall, right? Alright, so let me see my file again. And okay, another thing is that if you see here, we have a jointing wall here, Alright, in order for me to do this, I will not create the wall manually. One way to do this is by creating rib. To do rib, make sure I have this flat plane here, so I click sketch, so I can draw a single line. Make sure it snap at that middle point up until here, and I already know that this thickness of this wall is 1 mm. So here I can do rib. Okay, I already have this line, then I can do rib. Features, we have rib. So by default the rib is 10 mm like this. It's too thick, so I go for 1 mm. But as you can see, the projection of the rib, let me show you. If the projection of the rib is to the direction and also to backward direction. So this is the wrong direction. I want the direction to be pointing downward. So the setting on the left here, instead of the first one, I select the second one. So it means, can you see the direction of the rib is pointing toward this body. Sometimes if you click flip, it goes upward. I don't want it to be upward, so I uncheck the flip. So it means the direction, the projection of the rib is pointing to this direction. Alright, here about the selected body, I need to select this front casing here. So it's already selected, then I click OK. Now I have the wall. So this is fastest way for me to create the thin wall by using rib. About the other side, I can mirror it. I use mirror. So since my mirror plane will be it should be my top plane. Since top plane laying in the middle there. Features to mirrors, carefully select at this viewing orientation. I select here, so it's already reading the rib, then I click OK. Now I have the this thing. Alright, let me save my file, and if I go back to the assembly mode, so I click yes, so it will be automatically updated. And now at this front casing, I have this supporting structure, so this is good enough. Okay, let me on the rear casing. Alright, as you can see here now, so this is a rear casing and this is a front casing. So it's kind of like this rear casing really grip, and this front casing, the supporting structures really grip the motor into fixed position. If I go for section view, I can show you section view. If you look at this section view, so these are pictures the supporting structures or from the rear casing. These are supporting structures, and at the end here we have kind of like a smaller diameter. It kind of like behave as a stopper to prevent this DC motor going to this direction. So it will make it will lock the DC motor into position. Same goes here. We have this thin wall here, kind of like smaller diameter. But one thing that I found out, this DC motor, as you can see, we have a metal connector here. So it means I got to do something. Actually, I make this part modeling of DC motors. I think the connector of DC motor should be reduced a little bit. It's kind of like we have overlap here. Alright, let me off this thing. So I will open this one, the DC motor open part in position. So the way I've done this metal connector, as you can see at this position, doing it by sketch here. And if I edit the sketch, so the sketch that I put from this position is 2 mm. So I think I should put it about, if I go for 3 mm, and to make it further to this further below here. So then, and this one is a mirrored representation, and if I save it and I go back to, hold on, I go back to the assembly. Right, looks that we don't have any interference. Okay, I think this is good enough. Then I will save my file again. Right, so I've done the supporting structures to hold this DC motor in fixed position. Alright, okay, I think I end up this video up until this position, since this video is taking too long. And later I will do the continuation in my next video, where I will show you how I will do the detailing of this rear casing and also front casing. I need to build a supporting structure or supporting ribs to hold the PCB. It means that I will insert my PCB and also my batteries. I will show you in my next video also the supporting ribs to hold the battery for both rear and front casing. Okay, inshallah I will see you in the next video, but before that, please do appreciate my effort to do these video tutorials by clicking like, subscribe, and promote my video to your friends. Assalamualaikum warahmatullah.